Welcome back. We're going to do an application problem similar to what you're going to see on your homework. The problems are all going to run through the same types of steps. It's just that the words and the variables that we are considering, the context of the problem is going to change, but they're all going to work the same way or ask the same types of questions. You're just going to be interpreting it differently. So we're just going to do this one demand problem. So in this case, we're looking at boxes of nails and dollars per box. So suppose customers at a hardware store are willing to buy N numbered boxes, N of P, boxes of nails. So N of P means boxes at P dollars per box, P being the price in dollars, given by this function. So N of P equals 80 minus 5p squared, where the p value is always going to be between 1 and 4. And so you could assume that the more money a box of nails is, probably the less people want to buy it. And then when it's lower in price or maybe even on sale, it's more likely to be purchased. So we have this quadratic function, and we're creating this domain restriction and just saying that price is always between $1 and $4. So the first thing we're going to do is find the average rate of change. Now, average rate of change is just slope. So looking at that average rate of change, we're looking at the average rate of change between p equals 2 and p equals 3. And we know our average rate of change formula is going to be f of b minus f of a, so the corresponding output values, divided by b minus a. In this situation, we're going to have n of 3 minus n of 2 divided by 3 minus 2. So I just need to plug 3 in and 2 into my function. And that is 80 minus 5 times 3 squared minus 80 minus 5 times 2 squared, all over 3 minus 2, which is 1. So we don't really need that 1 in the denominator there. So that gives me 80 minus 5 times 3 squared, which is 5 times 9, so 80 minus 45 minus 80, and then we have 5 times 4, so that would be minus 20 or plus 20, again, still all over 1. Those 80s cancel, and I end up with negative 25. So that is negative 25, and we have units on this rate of change. So n, my unit in the numerator, represents n boxes of nails. So we have boxes per dollar. And so what that is indicating to us is as the price increases from $2 a box to $3 a box, the quantity of boxes people are willing to buy decreases by about $25 per that dollar change. All right. Now let's look at part B. We're going to find and interpret the instantaneous rate of change of the demand when the price is $2. So what happens instantaneously, right at that exact moment? So what we did here, this is kind of akin to finding that secant line, the slope of the line between the 2 points on that graph. And now we're going to find the slope at exactly that point on the graph. So I have written our formula here that we're going to use, and we're going to use 2 in example B for our A value. So here I have the limit as h approaches 0 of n, we have 2 plus h minus n of 2 over h. Or rather, I have 80 minus 5 times, I'm plugging in 2 plus h for my p, So that quantity squared minus 80 minus 5, I'm plugging in 2 for P, all over H. And I see here I did not write my limit. We need to write that every time. So I've got the limit as H approaches 0. So we need to simplify this. We have the limit here as H approaches 0. That is 80 minus, if I FOIL this, I've got 4 plus 4H plus H squared. So 5 times 4 plus 4H plus H squared minus, and here I have 80 minus 5 times 2 squared. That's going to give me 20. So 80 minus 20 is 60, all over H. And just remember, if you're working these problems with me, you can pause and try to work this out yourself, and then get to the next answer and double check that you're on the right track. So we've got the limit as H approaches 0. I have 80 minus 20 minus 20H minus 5H squared minus 60, all over H. You'll notice 80 minus 20 minus 60 cancels. And I have the limit as H approaches 0 of negative 20H minus 5H squared over H. Factoring out that H in the numerator, I've got the limit as H approaches 0 of, I've got H negative 20 minus 5H over H. My H's cancel, and I've got the limit as H approaches 0 of negative 20 minus 5H. Of course, at this point, once I've canceled the H in the denominator, then I can take my 0 and plug that in. So I have negative 20 minus 5 times 0, or negative 20. So, as we just calculated, the instantaneous rate of change when that price is $2 per box is the demand is changing at negative 20 boxes per that dollar change. So negative 20 boxes per dollar. So essentially what we're saying, at around this $2 point, if we created a dollar price increase, say from $1.50 to $2.50, that would cause a drop in the demand of about 20 boxes. Less people would buy. So if that price increased from, say, $1.50 to $2.50, that $1 price increase, that's going to cause a drop in the demand, and less people are going to buy. So we're going to sell about 20 less boxes. So let's see what happens when we make the price even a little more expensive, say $3 per box. What is that going to do to this demand on boxes of nails? So what I'm going to do here is I'm going to encourage you to pause the video and set this up and solve it on your own. I'm going to pause, I'm going to work it out and write my answer to save us some time. So if you're ready, pause, set it up, and go. So what I have here is my setup for how I'm going to be solving the problem. So I'm using 3 plus h and 3. I'm plugging those into my function in the numerator. And working through my calculations, I end up with negative 30. So if you need to pause, go right ahead and do that. But I'm going to come up here and write this. We have negative 30 boxes or boxes per dollar. So what does this tell us for part D? As the price is increased from $2 to $3 per box, how is the demand changing? And is this change to be expected? Well, as the price increased, the demand decreased. So as we raised the price, less people wanted to buy. And this is an expected change. So um, that is the rate of change application problem. So you're going to see quite a few of these on your homework, and they're all going to be very, very similar to this. As always, if you do have any questions or concerns, please feel free to reach out because I am here and I am ready and willing to help. Thanks. Have a great day.